Yes, sir.
Last class we explained about that what do you mean by reclaiming space in files. So in this reclaiming space in files, we have seen that there are two different methods. Is there one is for variable length and fixed length record, and also we have seen that we have the two approaches. One is that linked list approaches, another one is that stack approaches. We should keep track of that deleted record. So that one is known as that avail list. So once you are going to find out those avail list from this one, we are going to enter from that we are going to find out that whatever that record space will be available, and on those record we are going to insert a new record. So this way we are going to reclaim that space. And after that we came to that one, there are two different types of searching technique. One is that sequential search, another one is that binary search. As all of you know that what do you mean by sequential search, also what do you mean by binary search. Now coming to this binary search, that binary search will be much more faster in main memory. If you will do it in secondary storage device or disk, it will be slow, because secondary disk is already, we know that disk is slow, so that's why it will take much more time if you have to sort, because in binary search, as we know that we have to sort the file, and after that we should run this binary search algorithm. So there are two different kinds of sorting is there. One is that internal sorting, another one is that external sorting. Internal sorting means we should do that. We are doing that sorting in main memory. So that one, or RAM. So that one is that internal sorting. So any kind of sorting, if you will execute in main memory, it will be much more faster compared to that secondary storage device. So if you are going to do that sorting in secondary storage device, again the same problem, as disk is slow, it will take much more time. So now next what we should do, that we should search any record, any file, the operation is possible like that, searching, deletion, addition, or modification. So these are the some of the operations which is we are doing on any file. So right now to search or to do such kind of operations, what we should do, that we should write program. So as we know that once we are going to write that program, that particular program, journey of byte, in which we have seen that once we are going to write that program is going to load it into main memory. Now if you have to search, then what we should do, that we should bring that particular file into main memory. So there are different types of data structure we are studying, that how we can make this searching faster. So for that reasons, what we have to do, that basically we have seen that the file hold the content. So if in a file there are n number of contents will be there, so all the content of that particular file has to bring into this one. If you will consider this one is that main memory, so we will bring it into main memory. But in this one we have seen that one constraint, if the file size is big enough, so at that time it's not possible to load whole the file into the memory. So yes, we can't load it into main memory, then what we are doing, from this particular file we are making from this file, or there are a number of records will be there. From those records we are going to extract only the key part. So we are going to extract only the key part, and that key part only, if I will consider this round shape as a main memory, we'll load that particular key part into main memory. So once we are going to load that key part into main memory, then what you are going to do, you are going to sort this particular key part. So this one will be sorted, and this one will be unsorted. So unsorted one, we are going to load it into main memory, and after that we are going to sort it. So this technique, so once we are going to sort it, so we'll get it into sorted order, and after that whatever the files will be there. So this one was, or this one was your file. So whatever that file content will be there, so it will be in same format. So that sorted one is going to be pointing to that corresponding location where that particular record will be there, where that record will be there. After that second time, this is the for first time. So after that second time, what you have to do, we should write down that particular data file in sorted order. So for example, this one was 3, 2, 1, 4, 5. So I should, second time I should write it into secondary storage device in 1, 2, 3, 4, 5, 6, like this in sorted order, so that it will pointing to that first one first, second one second, third one third. So like this it's going to point. So this technique is known as that key sorting. So we have seen that this technique is known as that key sorting. So in key sorting, first what we have seen that we should create one key nodes. So that key nodes, it's going to contain key nodes. It's going to contain what? Key nodes, it's going to contain two things. One is, anyone, last class we told, no? Hello, that key nodes is going to contain what? Either you are not listening or you are not understanding two things. Key node is containing what? Hello. Is it audible to everyone? Hello. Is it audible or not? You can write it in chat also. Is it audible? Is it audible to everyone? Is it audible or you can't listen? Is it audible? Is it audible to everyone? Dipti, is it audible? Dipti, are you there? Sai Pranati, are you there? Deepika, are you there?
Excuse me, sir.
So is it audible?
Yes, sir. My signal wasn't proper, so I was not able to hear you. Can you just repeat, sir, little last one? So I had to exit and I had to enter.
We told that last class we told what do you mean by key sorting. So in key sorting, we told that we are going to make that key nodes. So in key nodes, what will be there? Key nodes is going to contain two things. One will be that key node is going to contain two things. One is that what? One will be key part. Another one will be relative record number. So key part and relative record number. So key file say that, for example, one, so it's a key node. For example, if I write down that key as, for example, 11 VA and relative record number 1. Now next one is that, for example, 5 VA, relative record number 2. Next 2 VA. So this one is that, for example, we are taking it's an USN number as a key part, and this one is that relative record number. As we know that what do you mean by relative record number? 2 VA. Next we are taking, for example, 7 VA. Next, for example, 4 VA. So like this 1, 2, 3, 4, 5. So this one will be that key node array. So first we are going to take that key node array. So this key node array only known as the unsorted file. We are going to load it into main memory. Instead of loading whole the file, only key node file is going to be loaded into main memory. Is that clear?
Yes, sir.
Okay, so once you are loading into main memory, after that what you will do? You will sort this file only. So this file has to sort. So once you are going to sort this file. So how you are going to sort this file? According to that USN number. So if according to that USN number, then it will be 2VA. Next one will be 4 VA, next one will be 5 VA, next is 7 VA, next one will be 11 VA. So after sorting, it's going to looks like this. So 1 V, 2 VA, it's pointing to which one? 1, 2, it's going to pointing to that 3. Next one is 5. Next one is 4. That 5 is for 2. Next one is which one? 7. So 7 it's for 4. Next 7. After that 11 it's for 1. So what does it mean? That the first one is, so the record will not be in sorted order. So this one is the original record. So 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. So these are the 5 record is there. So this is 1. This one is the 2, 3, 4, 5 record is there. So right now what that this one will pointing to so right now this one is going to pointing to which one? It's going to pointing to third record. Now next one is that this one is pointing to which one? This one is going to be pointing to fifth record. Next this one is going to pointing to second record. Now this one is pointing to that fourth record, and this one is pointing to that first record. So this one is that how key sorting. So after sorting, the file is going to looks like this. So after that, what you have to do? After that, you have to sort this data file. So after that, you have to sort this data file. So after sorting this data file, it's going to looks like this one. So first one will be that first record, second one will be that second record, third record, fourth record, and fifth record. So it's going to looks like this after second time. So first it's pointing to this one, it's referring to this location. After that we are going to sort the data file. So the data file will be where? The data file will be in secondary storage device. So after that we are going to sort this data file in secondary storage device directly, because according to that primary key. So this one is that how key sorting is going to work. And one simple class we define, in that class we define that key nodes of array. Key nodes of array, it consists of key and relative record number. That key and relative record number. And once you will make this one, after that we are going to read this file. First we are going to what? First we are going to read this file. From this file you are going to, if they will ask you that explain that key sorting algorithm. During exam I told that they will ask you that explain that key sorting algorithm. First you are going to read this data file. From this data file, so you can write down that pseudo code also. If somebody can't write that program in C++, if you have understood, so at that time you can write down that pseudo code also. So at least 70% to 80% marks you will get. So that first you are going to read the data file. From that data file you are going to extract the key and relative record number. So that one is for that key sorting. So once you have extracted that one, you are going to load it into main memory. So after that you are going for any sorting techniques. After sorting techniques you are sorting that file. Once you will sort that particular file, that file is pointing to the location where that data files will be there. After that second time you are going to rewrite that data file in secondary storage device in sorted order. So that one is that key sorting technique. Is that clear?
Yes, sir.
So once you will do up to this much, so after that this one last class only we explained about this one. So right now we wrote that simple class structure of what that key sorting. Now we didn't wrote that algorithm, so we'll write down that algorithm, that how key sorting it's working, and we'll see that what are the limitation of key sorting. So last class we wrote only that function for that class definition of that key sort. So now how that key sort algorithm is working in key sort that fixed record, as we are working with that fixed length record. So because relative record number, so relative record number it's applicable only for fixed record file. In case of that variable record file, we can't go for that relative record number. So fixed record file ampersand in file. So this is that file you are going to open in file character name of the out file where you are going to write rewriting. So I told that we should rewrite that file. So out file name that where you are going to write that file. So in this one, we'll write down first one record type object. Next key relative record number. And we know that key nodes we are going to define that key nodes equal to creating by using that new operator key relative record number. And in this one we are reading that number of record in files. So input files, what are number of records dot number of records. So now what will that we'll read that file and load the keys. So for I equal to, so how many numbers of record will be there? So for that reasons we need to know that how many number of record is there. So int I equal to 0, I less than in file, in input file how many number of in file dot number of records how many number of record is there in file. So that one we are going to write and I plus plus. So this one is that for loop defining. So in this for loop, first we are going to read that particular record. First record 0, record 1, record 2, record 3. So like this we are going to read. What I told that from that record, from that file, record file, we are going to read the record. So in file dot read by relative record number. Read by relative record number that object comma I. So those record or whatever that record, first 0th record, so each record it's going to read. So once you are going to read, after that what will do? You are going to put the key and relative record number into key nodes array. So that key nodes array, so key nodes array I equal to, so first key node array. So we have seen that key node 0, 1, 2, 3. So like this it will be there. So previous example you can see that this is key node 0, 1, 2, 3, 4. So like this you are going to read it. Key node array I equal to key relative record number object dot key. So whatever that key will be there and relative record number, first one is 1, 2, 3. So like this it's going to read. So once you will read it, after that what you will do? You are going to sort. So you are going to sort that particular key nodes array. That sort, which one you are going to sort? That key nodes and total how many numbers of records will be there in file, that many records you are going to sort. In file dot number of records. In file dot number of records. So this one is that you are going to sort those particular file. By using this line, you are going to sort the file. And after that, so this one is that first part. So you are going that, this one is that first part, that first you are going to reading those particular record from that in file, and after that you are finding how many records will be there. Each record you are reading by using this for loop, and you are keeping that key field and relative record number into this key nodes, and after that you are going to sort that key nodes file. Is that you are going to sort that key file. So whatever you wrote, you read in this for loop, that one you are going to sort it. Is that clear? This much is clear or not?
Yes, sir, it's clear.
Yes, sir. Clear.
Uh, so after that, what you will do that next? What I told that next time, output file, that you have to create one new file where you are going to. So this one. So where you are going to rewrite those particular record in sorted order. So next you have to write down that code for this one. You can write down pseudo code also. If you can't remember, maybe some people will be confused because it's linked with some other program. You will say that. So if you can remember those things, better to write down this code. If can't, then also you can write down step 1. If you have understood that what is step 1, step 2, step 3. So like this you can write down that pseudo code also. So I will try to give you notes with pseudo code as well as with this one. Who is comfortable with which one, they can write that one. So better to write this code itself if you can remember. Somebody for someone maybe it will be easy to write down that pseudo code so they can easily remember, they can do that one also, but it will be second option. Now next is that you have to write it. So first you have to open that file, out file dot create out file name. So this one is creating a new file. Now what you have to do, you have to write it. Now we have to write it into sorted order. So first you are going to read in sorted order, and after that you are going to write it. For int j equal to 0, same thing. Same loop we can write down here. We are this for loop. I am not writing again. So same for loop you will write it here. So j plus plus. So this is the same for loop you are going to write here. So after writing this one inside, what you will write down? You will write that same thing, that infile dot read by relative record number, read by relative record number. So what is that relative record number? That one is that object comma keynotes of j, keynotes of j dot relative record number. So this one is that read in key order. So it's going to read it in key order. Whatever that key order will be there, on that order it's going to read. So this one is that reading in key order. So what does it mean? It's going to read. So this part, this red line, you can see that what we explained. So read in key order. Is that clear? So that part is that this inside this for loop, first one is that to read in key order. So right now 2AV, it's in third position. So 2AV it's going to read in third position is which one? The third position. So after that 4VA, it's in fifth position, it's going to read. After that 5VA, it's in second position, it's going to read into second position. So same thing here in this code also, read in key order. So it's going to read in key order. After that, what you have to do after reading, it has to write it into key order. So how you will write it? That out file, that name of that file where you are going to write out file dot append and that object, whatever that object we are going to read. So that objects you are going to write and return 1. So this one is for reading in key order, and after that you are going to write in key order. So this is all about this key sorting. This is all about this key sorting. Is that clear? So just look into this code once I can just check that whether is it clear or not. That key sorting, it's also known as that tag sorting. So first what you have to do, first if you will write down, if you have understood that, you can write that pseudo code also. That first what you have to do, open the input file as what? Open the input file, I will write it in. Have you understood, or again I should write in pseudo code? Let me know.
Understood, sir.
Okay. So then I will not write in brief. I will explain how you can write down that. First of all, you have to open the input file. After that, you have to create one output file. So first step will be read that particular record from input file and sort and extract that key nodes, that key field and relative record number, and copy that and load that particular file it into main memory. And after that, you execute that sorting. So once you will sort it, after that what you will do? Once you will sort it, after that again you are going to read. So you can see that now only what is that limitation. First you are going to reading that file in key order. After that you are sorting. Once you will sort it, after that you are going to read it into in key order. Once you will read it into in key order, again you are going to write it into key order. So here you can see that what is that main disadvantage. You are running this for loop 2 times, whereas only one time it was okay. So 2 times executing this for loop, it will take much more time. So that overhead, it's going to increase. So this is that one limitation for that key sorting, that reading once, writing, that writing in sorted order once, that key file after reading through that sorted order in key by using that key file, again write. So this one is that reading by sorted order, and after reading again we are writing it. So 2 times we are doing that. What is that need to write it again? This step is absolutely not required. So as I told that previously, here if you will go, for example, yes, so here if you will go, so if I can read it, I can keep it here itself. Next, I no need to go for rewriting it into sorted order. So this one is the disadvantage. So this one is the disadvantage of key sorting. That this for loops we are executing 2 times, one for reading that once for what, once for reading in once for extracting this key field, and after that sorting that key field. Second time what we are doing, second time we are going to read it into sorted order, and again we are going to write it into sorted order. So it's not absolutely required. So this one is the main disadvantage of that key sorting. Reading records in this twice is not required. Is it required? Once you are reading for this one, see here, once you are reading to create this file from this, again you are reading to, again this is that first time reading, this is first time read, and this one is that second time read. This is first time read, this one is that second time read. So reading records in disk twice, is it required? It's not required. For that, a lot of seeking time it's taking, a lot of seeking for records for constructing new record file. So after reading, what you are doing, you are constructing that new sorted file. Is that clear or not? This what is the disadvantage? You can see that once you are reading this file, to sort in key order. After that, to write it into sorted order, that file second time you are reading. So 2 times you are reading. If you will go to this code, here also you can see that 2 times you are reading. So one for this one, another for this one. So this 2 times reading, absolutely it's not required. And writing again in sorted order. So that one is the main disadvantage of key sorting. Is that clear? So it is very, very important question. During 99% times they will ask what is the limitation of key sorting. If you have understood, you can write down the diagram or that code and you can explain that what is that disadvantage of key sorting. So this one is that limitation, or we can say that disadvantage of key sorting. An advantage already, you know that what is that advantage. No need to load the whole the file into main memory. Only key part we can load it into main memory. In this way, it's going to save lots of space, and we can run that internal sorting algorithm, which will be much more faster. Is that clear?
Yes, sir.
Can you? So the questions will come like this. What is key sorting? What are the advantage and limitation of key sorting? Explain key sorting with C++ program. So you should write down the first class definition, and after that you can write down this particular code. If not, you can write down the pseudo code. So that one is that key sorting. So 99% time this question is coming. So keep it in mind. What is key sorting? What is the limitation of key sorting? What is the advantage of key sorting? Write a C++ program for key sorting. So from this second unit, very specific question. So whatever question telling, those things only will come. One is the data compression. Any one data compression techniques, you can write run length encoding techniques, or Hoffman encoding technique, or Morse code, or by using different notation, or they may ask you explain that run length encoding technique, or they may give you some problem on Hoffman encoding technique. One question over. Next question is explain reclaiming files, explain reclaiming space in files. So this is second question over. Third question, what is key sorting? What is the advantage and disadvantage of key sorting? Explain key sorting in C++ using a C++ program, or write that algorithm for key sorting. So these three questions, 99% time, any two questions will get. So this much only. I told previously also that first unit having lots of questions, and it will take some time. So you can give your own. I will try to upload the notes or prepare that note. Not getting time, we'll prepare it and we'll share with you as soon as possible. So first unit will take some time, so you can give your effort for that first unit. Okay, and second, third, fourth, all those things, specific questions will come. If you'll understand, you can write it very easily by yourself. So hope so that no need to go. If you have understood after class, you can note it down. What are the points you have to write for exam? Notes will be provided, but it's better whatever discussing, if you'll keep in mind those points as to write, so it will be very easy for you. So this way you can do it. So these are the three questions. So more specific. Now no one can give you question paper. So this is the more specific questions. So you should learn this all three questions. Any one question, two question, or one question, at least one question, 100% you will get. Your good luck is there. So you will get two questions definitely. Okay, so 90% time two questions you will get, whatever the three questions just now I discussed. So this is about that key sorting. So is there any question from these three topics? One is that data compression, one is reclaiming space in files, one is key sorting. Is that clear?
Yes, sir.
Hello? Okay.
So,
So now in this chapter only, because each unit will be of two parts. So almost second unit, half part we finished. Okay. Second unit, more than half part we finished. Second unit, it's remaining only indexing. That is very, very easy concept, indexing. You can write very easily that answer for any question. So we'll go through that second unit. So this almost half of the portion of this second unit, half of the portion of that second unit finished. Now next another one is that pinned record. So this one is easy, that pin record. If you have understood that key sorting, it will be easy to understand and why we are moving to indexing. Before that, solution limitation, solution we'll write down. Okay, that key sorting, what is that solution? That one first we'll write down after that pin record. That solution, that why two solution is there. So we know that right now what is the limitation of key sorting. 2 times reading. And what is the need to write it back? It's not absolutely required to write it back in sorted order. It's not required to read 2 times. So what solution we can provide? So we can provide 2 solution. That 2 solution, why bother to write so many students, why they are not attending other classes? Only how many? Why others is not attending? Do you have any idea? Or not taking attendance? That's why. Hello?
Don't know, sir.
Not taking attendance. So I should again have to take attendance if people are doing like this. At least you can attend, and if you have any problem, you can discuss. Whoever not attending, I don't know why. So at least they should attend during exam, because if exam will be there, so at that time they will say that we don't know anything, all such kind of stuff they will start. So I hope so that I have to also take attendance as people are not attending, isn't it? You just inform them why they are not attending. If it is like that, I have to take attendance. Is that okay? You just inform others. You have your students group, isn't it? So
Yes,
there
sir.
you, there you just put that message. If it is like that, number of people are attending less and all those things. Again, they will for them. I don't mind that if somebody is attending or not, but they should attend. As this one is lockdown, so they are roaming around or what they are doing. Don't know why they are not attending. So if it is like that, that I have to take attendance or I have to call each and everyone to their parents that what is the problem, why they are not attending. At least have to know that what is the problem. So you just put that message to attend the classes. Fine.
Yes, sir. I'll put.
So two solution that why bother to write file back. So first one is that write out sorted. You can if you have understood, it's easy. Write out sorted keynotes array without writing record. Write out sorted keynotes array without writing records in sorted order. So what does it mean? So here you have seen that in previous, for example, here what you have seen that uh, uh, we are reading those file in sorted order, and after that we are writing in sorted order. So they told that why to write out sorted keynotes array without writing records back in order. Is that clear? Write out sorted keynotes array without writing records back in sorted order. So only let us write that keynotes array only in sorted order. So solution is that we'll write down that keynote array in sorted order. So first we'll write down, yes. So first we'll write down which one? First one will be 11 VA. No. So this one. So writing this one is only enough. So writing this part is only enough. So this one is that keynote array we are writing in sorted order. No need to write down the record file in sorted order. Is that clear? This write. This one is for write keynote array in sorted order. I will write in brief. Write keynotes array in sorted order. No need to write the data file in sorted order. No need for data file. Is that clear? So this one is that one solution. Just write that keynotes array in sorted order. No need to write the data file in sort order. So this one is that one solution. After that, second solution is there that keynotes array is used as index file. So now only that concept of indexing is coming. So you can see that just keynotes array. So right now this one is that keynote array. That keynote array will be used as index file. So in index file, what we know that index file there will be two things will be there. One will be key field, another one will be reference field. So that's already we have this key field. For example, 2V, it is in the relative record number is 5. 1VA, so 4VA relative record number is 1. Next 7VA relative record number is 8. So let us use this keynode array as index file and let us point to that location or jump to that location from this keynode array file. So this one is that second solution. Let us consider this one as an only index file and we'll use this one first. We'll write this key node array instead of writing the data file, and let us use this key node array file as an index file. So that one is the solution for key sorting. The whatever that limitation is there, the 2 times you have to read and after that you have to write back the data file in sorted order. So instead of that one, what we can do that we'll write down only keynotes array and we'll use that keynotes array as an index file. Is that clear?
Yes, sir.
Okay, so now next is that what I told that pinned record. So the pinned record is nothing but that record so records that are referenced to physical location of themselves by other records. So very simple way, we know that reclaiming space in files, for example, this one is that file. So in this file, what will happen if a record has to be deleted, we are going to mark with some special symbol. Let us consider this at that special symbol. We mark 2 record has been deleted and we are creating one avail list in which there will be 2 space will be there. One is for example 50 and next one is for example 60. So that these are that reference is there. Okay, so right now what will happen that records that are reference to physical location. So this one is reference to what? This one is reference to that physical location. This one is reference to that physical location. So this reference only will be known as pinned record. this reference only will be known as pinned record. So right now, for example, I have that multiple numbers of record I. Next is record, for example, record I plus 1. So next one is that, so like this, next I have that another, so like this, so we have that n number of record. So right now this particular record has been deleted. So the reference of this record will be known as the pinned record. That physical location. So physical location means you know that, for example, I can define int x. Now I can define int ampersand y equal to x. So that reference variable, it's pointing to some other variable. So this one is that reference variable. This reference variable is pointing to some other variable. So some other variable already whatever is there in your program x. If I will write down x equal to 10, the value of y also will be 10. Now if I will change that value of y equal to 15, the value of x also will be 15. So this one is that reference. So it's working like a reference variable. So right now this record deleted. So whatever the deleted record will be there, so that one is going to be pinned. So this is only known as the pinned record, the record that are reference to physical location. So in this avail list, whatever the physical locations will be there, all those physical locations will be known as that pinned record. Why? We can't move. So any reference, if you'll move, so it will change. It will give you the dangling pointer. So right now, for example, I can't define. So for example, I can't define another record, that record I. So another record I can't define into, for example, another record I can't define into this particular location. So that this one will give you that dangling pointer. So you studied that, what do you mean by dangling pointer in C. So that pin records make sorting more difficult. So if multiple numbers of record will be pinned, if reference variable will be there, so it will be more difficult, and sometimes it's impossible only to sort. So right now pinned record, if there are many numbers of reference will be there, and to sort those reference you will get dangling pointer. If some other values, if you want to put it into this one, if you want to move that pinned record or reference variable, because it may reference to someone. As I told that it's pointing to some data, this one is pointing to some record, this one is pointing to some record, this one is pointing to some record. As you are referring to some file, so for that reasons, once you are deleting, and after that again, if you want to reclaim that space, and you have to sort it. So at that time, it will be more difficult because it will create some dangling pointer. So that one is known as the pinned record. So record that are reference to physical location of themselves by other record, some other record. Here I have given one simple variable x equal to 10. So ampersand y equal to x. So x is now that physical location for y and x is same. If physical location of y is 0, 2, for x also 0, 2. For both x and y is going to be pointing to that same location. Now if I want to put another variable in this one, so at that time it will give you that dangling pointer. So that reference will be the same, so we can't change that reference. So not free to alter physical location of records. We can't alter that physical location of record for avoiding dangling reference. So to avoid the dangling reference, we can't do that we will move this physical location to some other record, we'll bring back some other record on that physical location. For avoiding dangling pointer, as we know that dangling reference is a very critical issue, so it will make a more hurdle for that programmer to find out where are those memory leakage and all those things is there. So for that reasons, it will be impossible for the programmer. So that solution for this one, what is that solution is that we have only one solution, that one is known as that indexing. We have that solution for this, that one is known as that indexing. While keep actual data file in original order, will not in this one, what we told that we are going to, for example, in this one, what we told that we are going to rewrite that file in sorted order. So we are going to rewrite that file in sorted order. So we'll not write it into sorted order. It will create the dangling pointer reference and it will be more hurdle. So for that reason, what we can do that we can use that concept of indexing. Let that original file as it is. Let that original file as it is. Just keep the pointer to that reference field. So use index file while keeping actual data file in original order. So that one is only the solution for pinned record. So in this one, that solution is that use index. That solution is that use index file while keeping actual data file in original order. So actual data file, which one is there in secondary storage device, will keep it in its order only, in actual order, will not change in data file. Only index file, that means key file. Key sorting, we know that keynotes. Let us consider, as we didn't go to that index file, keynotes also known as that one index file. So use that index file, we'll sort that index file only instead of rearranging that actual data file. So that one is the solution. So as for that pinned record is nothing but it's reference to some physical location by some other record. Is that clear?
Yes, sir.
Okay, so with this one I am ending today's session. So we'll continue in next class with that indexing. Thank you everyone for listening.
Thank you, sir.
Thank you, sir.
Welcome.
Thank you, sir.